All right, and sometimes you're putting strain gauges on non-metallic surfaces. It could be composites. This is a picture of some asphalt, some reinforced concrete, and this is a photoelastic image of the strain distribution in aggregate in concrete. It's basically a model of it. And kind of the opposite approach to what VJ was talking about. Here, oftentimes you want to pick a larger size strain gauge. And the reason for that is that when you look at the strain along the surface, it's changing. So, and a lot of times what you're doing is coupon testing or samples. So to get more repeatability from one sample to the next, or from one location to the next on the same sample, a lot of times you pick a little bit larger size gauge. Like in the case of the short one here, the smaller one, it captures more of the strain right over top of the piece of aggregate. And when it does that, the strain levels are lower. Where if you were to pick a larger size strain gauge, now you've got more of an average of the aggregate as well as the cement that's binding it. So you end up with a more representative strain of how it responds as a system. In general, we recommend picking a strain gauge that has a gauge length that's on the order of 3 to 5 times the aggregate size, or if you're on a reinforced composite, that you cover over at least 3 of the repetitions of those fibers. So when you look at your materials, let's say you are testing a reinforced composite, try to pick a gauge that covers over at least 3 of those repetitions. It makes it more repeatable from one sample to the next. It makes it more repeatable from one location to the next.